a good one if you want. So welcome to our CCNA 3 class, folks. This is our second meeting, our real first meeting of the class in terms of class content and information. I do want to still go over a couple things. All of you in the class right now have done your first assignment, so thank you very much for doing that on inside of canvas.stanley.edu. You have also, all of you, either been enrolled by me into the NetAcad class, or you have completed your seat token. So you used your seat token. So one of those two you have done. So thank you very much for that. I really appreciate it. Otherwise, the only other thing you will use this for, quite honestly, is just to get into the O'Reilly database if you want. Although I can also put that inside of our ENSA course on NetAcad. So this will be primarily where we're going to be working from. Now, I do want to talk real quickly about how you do your packet tracers and how you complete the packet tracer activities. So as you can see here, one of the first things you're going to have do is an assignment that is a packet tracer for single area OSPF configuration. Well, this particular packet tracer is 2213. So what you would do if you wanted to complete this and turn it in for me is you're going to go into the course content. And a lot of people ask, why don't you do links to it? Well, that's because the curriculum does change and the links change. And so I just ask you to go into the curriculum, click on the course index. This is how I teach my students also. Uncheck everything except for packet tracers. And then you will see the packet tracer for point-to-point single area OSPF configuration. Click here. It will take you to the page that has that packet tracer. You download it right here, and when you do, it will download the PK file to your local machine, or it could open it up directly depending on how you have your machine configured. Open it up, making sure you do have the latest version of packet tracer. If you don't have the latest version, where can you get that? Does anybody know? Where can you get the latest version of packet tracer if you don't have it already?
Well, you can get it in NetAcad, right? And
go to NetAcad, and you can do it one of two ways. You can go to your student resources right here, and it will take you to the packet tracers downloads, okay? Or you can always go up here to packet tracer resources under resources and download the latest version of packet tracer, which right now the current version is 8. Let's see, what is it right now? 8.2 is our current version, 8.2. So make sure you download that. And I do recommend the 64-bit download because of the size of some of the large packet tracers, not necessarily in our class, but in other versions of the class itself. So just be aware, 8.2. But once you get that, go ahead, Jeff.
Sorry, Kelly's the Mac version, is it on the same numbering scheme?
It does. It does work also. The Mac version, I will tell you, has some quirks at times. But the Mac version will work, yes, but it should have the same nomenclature. Let's check and make sure.
It's 8.2 as well.
8.20 also, yeah. And there is an Ubuntu version. If you want to actually, run it on a Linux, pure Linux box, you can do that too. In fact, that version is actually pretty stable. The Mac version, I will tell you, does have some quirks at times, but it works okay. So just be aware if you have a problem with the Mac version, just let me know and we'll try to help you through it. I don't personally have a Macintosh, so I'm a little bit hamstrung if I have to try to help you with it, but I'll try my best, okay?
Well, are there any of the Mac people? I've used it and I've had good success with it. The only problem I've had with the Mac version really has been when taking the tests, sometimes opening up the packet tracer files from inside the test. Sometimes it works and sometimes it doesn't. It worked better in CCNA 2 than it did in the 1 class, yes. But sometimes I've just had to, sometimes I just guessed at an answer and kept going just because the packet tracer file just wouldn't open up properly. That's typically the only problem I've had. Occasionally it'll crash and burn on me, but the more recent version hasn't been too bad about that. But the test files, when I'm inside a test and I got to open a packet tracer file, that's where I've had the hiccups.
Problem I've had with
go ahead, Linda. Sorry.
The packet tracer on my Mac, and I've seen this with my students, is it will say you did not complete something inside the packet tracer, but yet when you do a show run, it's right there. It's been done.
Okay.
The other thing I've noticed too is if you don't save them to the desktop, the PKA file, like when I downloaded this PKA file, it went to my downloads. I've had people with Macs have problems if they don't save that PKA file to the desktop of their Mac and then have it open from there.
Yeah, mine automatically downloads and saves it
Right.
to a
This,
specific
I will tell you
folder.
too, the item right here, this system test. When you install Packet Tracer, run the system test because it will run through and see if your Packet Tracer version works. Let me give you the other caveat. If you've ever had any old version of Packet Tracer on your machine at all, go into Windows and remove all, or go into your Mac, remove all versions of Packet Tracer previously to 8.2. Reboot your machine,
Mm-hmm.
then reload the new version. Because I have seen stuff left over. And in fact, you can actually have more than one version of Packet Tracer loaded on your machine at one time, and you can open the different executables. But so loading 8.2 will not remove the old version. And so you can end up with some real weird stuff happening. So unload all versions, remove all versions, reboot your machine, load 8.2 if you don't have 8.2 on your machine. And I suggest that in your classrooms also, because you can get into some serious trouble if you don't. But once you load it, run this system test and it will let you know whether or not Packet Tracer is working. This is especially true, Jeff, like you said, for those exams that have Packet Tracer questions on them.
Mm-hmm.
This will make sure that's going to work correctly for you. All right. So we've got it downloaded. We're going to do our Packet Tracer lab itself. So we're going to, go in here and do all the configurations, everything. Remember, I would like for you to do a check results and do an assessment item and give me a picture of this. Save a picture via snipping tool, whatever you want to save it as. So just take your snipping tool, and then you're going to upload both that picture and the .pka file to our class right here. So for each one of these uploads, there should be a PKA file with your name, then 2.2.2.13, and then a picture showing your check results. So when you upload right here, you'll be able to upload it and I will be able to grade it. The reason I asked for that picture of the check results is so I don't have to open every single one of these in Packet Tracer. Okay, does that make sense? You will see an upload here. I don't see it because I'm not currently in the student. So if I view this as a student, this is what you're going to see. You're actually going to see down here an upload item to add your submission. And when you add your submission, you can add multiple files. So just drag the PK file and the screenshot you did here, save changes, and it gets saved for me, and then I can grade them. Okay. So any questions on how you complete and upload Packet Tracer files for our assignments? I think most of you have had a class with us already, so this should be fairly familiar for you. Okay. So I'm going to switch back here to show you the next items you will have. The other items we have are our labs on NetLabs. Now there are a couple labs that are actual just paper labs, but we have NetLabs. I went in today, and typically when you do a lab in NetLab, so you're going to reserve a lab for yourself, you go in here, and let me back up because I did it a little quickly. But if you're logged in, you go new lab reservation. So I got my CCNP students are working on labs. Schedule lab. You'll find your class, which won't be this 6,000 classes like I have, but it'll be this KFC NSA. All right. You'll pick the lab you want to complete, and I'm going to do single area OSPF at this time. Remember, there are much more than 4 pods. There are 20 pods. So hit this button to go out here, especially since most people don't ever realize that that button is there and they think there's only 4 pods, but we have 20 pods available. So go out here and find a pod you can use. The red line is right now. You can schedule in the future. If you knew you had time Thursday at, 4 o'clock in the afternoon to do a lab, you could schedule a pod during that time. But I do suggest going out into the higher pod numbers because I'm gonna tell you a little bit about extensions and those things. Typically, when I do a lab, I try to reserve for myself, especially for most of the labs in this curriculum, 2 hours or so. So let's say 2 hours. I did 3, but let's say 2 hours here. Let me back down to 6:30. So let's say 2 hours and 1 minute. submit it. So right now that pod is booting up for me. And in my lab, in my data center at Stanley, the devices are actually booting. If at the end of 2 hours, I need more time, as long as no one has a reservation directly after me, I can request an extension and get another 30 minutes. All right. Now, the problem is, you noticed if I go down here and I do a reservation in the first 4 pods, okay, so I'm going to back down and just act like I'm going to do one. The first 4 pods are normally in use a great deal. So if you had a reservation and someone is within 30 minutes of you after your reservation, you can't request an extension. But if you go out here to pod 11 through 20, rarely will there be a time where if you start to run out of time that you couldn't ask for an extension. It does happen, but typically there's room up on the upper end of the pods to be able to ask for extensions. I would give myself 2 to 3 hours for each one of the labs that we have in CCNA 3. And then you do have the ability to do up to 2 extensions. So that's an additional hour. Okay. By default, it only gives you like 30 minutes to an hour. It only rounds up to the first hour after your reservation time. So don't make the mistake of clicking here and just go and submit, because see, I just only gave myself 29 minutes. So with 2 extensions, I would have an hour and 29 minutes, but make sure you give yourself a couple hours when you do this. All right. A couple other things here. If you do happen to do yourself a reservation for way in the future, so let's say, for instance, that I've decided I want to do the lab on that, and I've got time Wednesday, the 16th, and I'm going to do it during my lunchtime on the 16th. So I'm going here at pod 11, 12, something, and I'm going to do one from 12 to 2. I got some time that afternoon to do a lab. Click submit. Okay. You'll notice it's now sitting in my list of labs coming up in the future. Okay, for this coming Wednesday. But let's imagine Jeff calls me and says, you got to be in a meeting on Wednesday from 12 to 2. All right, well, obviously I can't do this lab. Well, whether or not I'm here or not, that equipment boots up and it is in use and cannot be used by anybody else in class or any other class. We have about 700 students using our net labs. Okay, so if you're not going to be able to use this reservation, so you know you can't get in it, just click here and cancel it. So what I'm saying is, if you make a reservation, please try to use it. Now, I know emergencies come up, things happen. You may make a reservation, you miss it. That's fine. I'm not going to have a heart attack. Okay. But don't go in and do a bunch of reservations and then not use them, because it does keep the pods from being used by anybody else in the class or in any other class. Does that make sense? All right. So I'm just going to cancel that reservation because I'm not going to do that lab on next Wednesday. But right now you'll notice this pod is booting up. You also notice right here a content tab. And you will notice that this lab says it has been updated for use on NetLab. So if you were to go into our class and find the lab single area OSPF configuration, it looks very similar, very, very similar to what we have in NetLabs. But notice what's missing. The document that says this has been updated for use on NetLabs. Occasionally, the labs are different between NetLabs and inside of the curriculum. So when you are doing the lab inside of NetLabs, you must be using the document that says it has been updated for NetLab Plus. Now, I have made life easy for you. I went in and on every single lab we were doing on NetLabs, I converted it to a Word document. And so right here underneath your upload is the Word document that you can click, download, open up, and use for every NetLabs that we have. And you'll notice, okay, you may have to save it as a different name. I don't know why it's doing a protected name. Well, just save it locally. Now, why is that? Oh, there it went. Okay, now we're good. All right, so now I can do it. But now look, this is the one that I just took, was a PDF. Okay, it was a PDF in our original document. I saved it as a Word document. So you're going to do the lab, and if there's anywhere there's information that needs to be answered like this, which router is identified as the designated router, which is the BDR? What is the selection criteria? You would just come in here and put your answer. The BR It's on view only. Hold on a minute, I'm gonna have to save this file, save as. Enable saving, there it goes. So now I can go in here and make changes to it. So I'm going here. And let's say, where did I miss that? Goes right, okay. The DR is blah, 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 okay? Now, if you can, it would be very helpful to me if you can change the color of the text to like blue or something so I can see it a little bit easier. But then all you're gonna do when you get done with your NetLabs is save this with your name, and you are gonna upload it just like you do the packet tracers right here. Now let me let you in on a dirty little secret. The great thing about NetLabs is every single thing that you type in to the console is saved for me to look at. So that's a beautiful thing. It catches my students a lot of times because they'll come in and say, oh, I did lab so-and-so, and they'll upload it, and I'll go and look, and I can look and see, hey, you never typed a single command in there. So it's kind of hard for me to believe that you actually did this work on your own. But everything I type in here, okay, is going to be saved, and I can review it. So you don't have to do anything inside of NetLabs to save anything for me. Now, if you want to do a copy run start, feel free to. It doesn't hurt anything. Everything gets wiped at the end anyway. But when you fill out this document, you'll fill out the document and you will upload it with your name to our upload item inside of netacad.com. So you'll see every single document I have put down the document for you to use if it is a NetLabs lab. Now there's one or two in here that's like this research broadband option. I didn't put NetLabs here because that's not a NetLabs lab. That's just a regular lab. So you use the document from inside of the curriculum. Okay. I hope those of you who've been through many of our classes have noticed how little actual content's in this class. There's not that many labs. There's not that many packet tracers. That's why, even though I don't require you to do every single lab and packet tracer, I only require 80%. I really do think in this particular class, you can do all of them fairly easily, honestly. Okay.
I have a question.
Yep, go ahead, John.
Is the textbook the same, or have they upgraded the online curriculum since?
I don't have that book, so I don't know how close it is, but I think it should be fairly close. As long as it's the new version 7, which if it's ENSA, it should be very close. Yeah.
Right. Thank you.
Yeah. I don't have that one. No, I apologize. I haven't ordered that particular book, but it should be close. Okay. Any other questions of how we do assignments or items are due inside of? Yeah, go ahead.
How do we, you're saying that you require us to do at least 80% of these labs here, correct?
Yep.
So for the ones that we have to do the net lab, there is no taking of the picture. We just go in there, do the lab, answer the question in that Word document and just submit it.
Correct.
Okay, and are we restrained on how far ahead we can get, or what? How is this governed?
No, you work as fast as we want to.
Okay,
I mean, if you want to do all the labs, if you want to go ahead and finish up, that's fine. I mean, if for some reason you've got to go ahead and finish up and get done with the class, go for it. Just let me know and I'll try to grade and get caught up and get you. Let's say for some crazy reason you need to teach CCNA 3 in a month. If you get done with it in a month, I'll accredit you. Okay, so that's the thing. I'm not, you can work as far ahead as you want.
Okay.
The other thing is this, you'll notice the module exams. Okay, so we do have module exams, obviously. I give you 10 tries on the module exams with no need for me to reset them. So I'm not using them to try to give you a grade. I'm using them for you to learn the material. One caveat, the final exam in CCNA 3, you must make a 70 or higher on it if you want the voucher, which gives you a 70% discount on the CCNA. And that must be on the first try. So you only get one try on the final written exam to make a 70 or higher. You should all make a 70 or higher. Don't make 100, but you should make a 70 or higher. I'll leave it at that. Okay. That way you will get your voucher and you'll be able to take the CCNA if you want to. Any other questions about how we're the class is designed and what you need to do in terms of completion? But that makes sense. That answer your question? Okay, we good?
Yes.
Okay, excellent. All right, any questions on NetLabs? Any problems? Everybody's able to get into NetLabs? Everybody has, like I said, remember the great thing about NetLabs is this is real gear. I mean, this is a true, 4000 series router sitting there. So 4300, 4321. These are real switches. These are not any way, shape, form, or fashion a simulation. So it's the real deal. This particular lab has no virtual machines, so there's no virtual machines out here, but some of the labs may have virtual machines on them. Okay. No questions? All right, well, let's do this. Let's jump into actual content then. Real quickly, somebody tell me, I use this massive, wildly crazy and sophisticated tool for my online instruction called Notepad. Tell me one of the types of routing protocols out there. There's two main types.
Link
You talking
state.
about the distance vector or
We got both of them right there. You have link state and distance vector. But we're actually going to break them down a little bit more than this. Let's back up. What's above link state and distance vector?
Static. Well, you said protocols, sorry.
Yep.
We're talking
Protocol
about static,
types.
Static.
Nope. Static, we got dynamic protocols. Do you remember about interior gateway protocols?
Gateway, right.
Okay. And then what's our other protocol?
Exterior.
Exterior.
Exterior, right. Now, how do we define these two types of protocols? Does anybody remember the concept of an autonomous system? Remember, autonomous system is a group of routers under the
Right, that shares,
control.
right, that's under the one administrator.
Yep. I almost say administration because it may not be one administrator, but it's administration,
Right.
same thing.
Right, just one person that administrates.
Usually running the same protocols. Same protocol. Okay. Or group of protocols. All right. So interior gateway protocols are protocols that are within an AS. Okay. And we have DVs or distance vectors that are there, and we also have link state that are there. So when we think about our distance vector protocols that are underneath this particular branch, what are some of the distance vector protocols we know about?
RIP.
RIP's one, V1 and V2, right?
Yeah.
And RIP V2. What's another one? Bun, Jeff, either one, John, anybody?
GRP.
Yeah, GRP is actually a distance vector. A lot of people, for years and years, the curriculum taught it as a hybrid protocol, and it's still a hybrid, but it is a distance vector at heart. A lot of times you'll also hear it called, sorry about my phone over there, y'all. A lot of times you'll also hear it called an enhanced distance vector routing protocol, but it is still at its very heart a distance vector routing protocol. Now, remember too, old school IGRP.
Yeah, what about plain old IGRP?
Yeah, exactly. And it is 100% a true distance vector routing protocol. Okay. Now, what about under link state? What do we have here? There's really just two of them. One we're going to talk about today.
OSPF.
IS or is. Yep. Okay. Now, exterior gateway protocols are between
BGP.
AS and somebody said it. I heard
BGP.
AGP and
BG.
BGP. Yeah, BGP. Those are the EGP is a precursor to BGP. It's no longer in use. So really, our only border gateway protocol that we have, or external gateway protocol we have, is the border gateway protocol, which is BGP. BGP, by the way, is called a path vector protocol. It's not a distance vector or a link state. It actually works a little more like a like a distance vector protocol than a link state in a lot of ways. But it's also just its own beast, 100%. BGP is I call it the coffee cup protocol because you'll make a change to BGP. You need to get up, go get a cup of coffee, then come back and check to see if the change is actually propagated through your routers, because BGP is just a weird beast. These right here under the distance vector protocols, when we think about distance vector, we also think of the term many times of routing by rumor, because typically in distance vector routing protocols, you only know of the information directly from your neighbors. You don't know the overall topology or information about the network, whereas link state typically has a better overall topological view of the network. Okay. Now, OSPF is an open standard. By the way, EIGRP is now an open standard. It has been submitted as an IETF standard. So although it's, you'll still see in many textbooks, it's called a Cisco proprietary protocol. It is proprietary, but it's an open standard. So it's a weird little beast too. It's super fast. EIGRP is stupid fast. It is a very good protocol, but many people go with OSPF because it is a truly open standard from the very beginning. Okay, so OSPF as a link state protocol has some very interesting items about it. Any questions about these here when we talk about these? Like I said, I always like to talk about interior gateway, exterior gateway protocols, and then inside of the interior gateway protocols, we have distance vector and link state. And then inside of the exterior gateway protocol, we just have path vector protocols, which are BGP is really all we have. Now, we don't even discuss BGP much anymore in the curriculum. We used to do single or simple neighbor relationship OSPF in CCNA. We don't do that anymore. That's been moved into CCNP. So if you want to learn a lot more about BGP, we have to go over to CCNP class. Any questions about these before we move over to the curriculum here? Okay, so what are some characteristics of OSPF? It is a link state protocol, which means it's going to have a couple things in it that other protocols may not have. Now, one of the things about OSPF is OSPF contains more than one table. It has a neighbor table. It has a topology table. And then it has a routing table. Now, you think about the very reason why OSPF would take more memory and more processing power off of your router is the very fact it has to maintain 3 tables. How many tables does RIP maintain? Anybody remember? Just one, right? It has a routing table. That's all it has is the routing table. That's it. Now, I will tell you that EIGRP and OSPF both contain, these actually do have neighbor tables, topology tables, and routing tables. So that's why a lot of people call this a hybrid protocol, because it's got some of the characteristics of a link state and some of a distance vector. The other thing we typically think about with distance vector is we think about a concept called periodic updates. In other words, every 30 seconds, RIP would send out its route table to all its directly connected neighbors. That is different than link state, which typically does what we call triggered updates. So a topology change happens in the network, a link goes down, boom, that gets sent out. And by the way, that's called a link state. A link state changes. A link goes down, the state changes, that gets advertised. But OSPF does have these 3 tables and maintains them in order to build the routing table and find the best path. So when we look at OSPF, that's why we have hello packets. We have hello packets to establish our neighbor relationship. We have database description packets to build our topology table. And then we have link state requests and updates to also request information for the topology table. And then some information is actually, when you do a request and you get an update, some of that information is acknowledged, some of it is not, depending upon what type of information it is. But inside of the link state, here's how OSPF works. One, everybody boots up and you establish your neighbor relationship. So you're going to send out your neighbor advertisements and say, hey, my name's so-and-so, my router ID is blah. and you're going to establish those neighbor relationships. You will then begin the process of exchanging information about your link states. Now, all that is literally telling your neighbors about all of, well, actually everybody, telling everyone about the networks you're connected to and what links they are. Each machine will then build a link state table using that particular information, and then they'll execute the shortest path first algorithm to create the shortest path first tree and choose the best route based on a cost. And cost is completely determined by the speed of the links between two different networks. Lowest cost is best cost. All right. Now, OSPF can do equal cost multipathing, but OSPF cannot do unequal cost multipathing. Just not able to do it. Okay. Now, EIGRP does that by default. So we do have two different ways it can run. We deal mainly in this class with just a very simple single area OSPF. Whenever there's only a single area of OSPF, it must be area 0. So the backbone must always be created first. But then, as you learn more about OSPF, go into your CCNP class, you will learn about the ability to break OSPF into multi-areas and use those areas to contain information in the database. In other words, the reason we would build this out is so that if a link went down in area 51, area 1 would not even know about it. And so we would summarize at R2 the networks in area 51. We would summarize the networks in area 1. And then that way, a route flapping in area 1 would not cause everyone in the entire network to do a shortest path first calculation. There's all types of different packets and control and areas. We have the backbone, we have regular areas, we have stubby areas, we have not so stubby areas, and we have totally stubby areas. We don't go into those in this class, but as you move forward, if you read about those, just be aware those are different types of areas in a multi-area OSPF network. Any router that sits between two areas or has interfaces in two different areas is considered an area border router. Okay, because it's literally bordering two areas.
But Kelly, so in this CCNA 3 version, they don't cover stubs and all that stuff?
Nope, not at all. It is absolutely just single area OSPF.
Okay.
The CCNA has been dumbed down immensely, especially the routing. The routing has been massively dumbed down, unfortunately. But now they do say the reason you would have multi-area OSPF is to make smaller routing tables. And that is true, because if you do it correctly, area 1 only needs to contain the routes. These routers only have to contain the routes for area 1 and a summary route to everyone else. Likewise, area 51 would know only the routes inside area 51 and a summary route to get to area 0 and area 1. If you design your network correctly, okay? So what we do at Stanley Community College is we summarize, and we don't really do, I don't know if we do areas or not as far as area 51. We could do it. We can make each building its own area and summarize the individual areas, okay? But typically you only do that if you've got a large number of routers inside of an area and you want to control
it's a single area.
Yeah, single area, but it's summarized with IP addressing at layer 3 is what we do for ours. Notice though, with this, the great idea is if this link drops, only the routers inside area 51 perform a shortest path first calculation, a recalculation. Nobody else has to, because it will never leave if you configured it correctly. Now, by default, it actually does leave the area. A lot of people don't realize that, but there's a type 3 LSA that will leave the area and tell everybody else about it. But you can fix that. You can stop that. All right. OSPF version 2 does not support IPv6. OSPF version 3 does support IPv6. That's pretty much just the main difference between them. Here's the thing you do have to realize: if you are running multi-protocol, in other words, if you have a dual home router doing both IPv4 and IPv6, you're going to have 6 tables. You're going to have a neighbor topology and a routing table for IPv4 and the same for IPv6. So if it's a small router with very little memory and very little RAM, be aware you can overstress the router running both sets of protocols on there. But it is possible. Okay. Here's our different types of packets. We've got the database descriptors. We've got link state requests, updates, and acknowledgements. Down here, I'm just going to show you these. Basically, a type 1 is a hello packet, which allows you to do your neighbor discovery. The type 2 is the database description, which is what you send out for the link state database. So when you are sending out, remember the second thing they do after establishing neighbors is they inform each other of their link states. Those would be database description packets. A link state request would be a router saying, hey, I need to know about network X. And then you could get a link state update from the person or the router in control of that particular network. And then a LSA ACK confirms the receipt of an LSU if you get a link state update. Okay. So all of these packet types are used to perform a specific function. I would know these 5 types, at least know the 5 types, not even necessarily have to know type 1 through 5. There's actually a lot more than this. There's actually like 11 to 17 different packet types. We only cover these. But just be aware, most of the link state updates or database descriptions have a subtype. So here they are. You can see our neighbor relations and see this is what I'm talking about. An LSA type tells you the type of update it is. So the type 4 LSUs or link state updates are actually broken down into multiple different types of sub updates. So router LSA, network LSA, a summary LSA, each one of these is a type of link being described. So if you need to know about the network 10.0.0.8/8, you would probably be getting either a network LSA or a summary LSA back as a link state update. So don't get confused by the link state updates and then link state advertisements. Those are the type of record that's being placed in an update. Okay. And this is where we get all kind of craziness, not so stubby, etc. But let's look first at a hello packet. For the CCNA, you're not going to need to know how the exact packet header type, but just realize that type 1 is used to do the neighbor adjacencies, and it's also used to elect what's called a designated router or a backup designated router. And we'll talk a little bit more about that as we move into running OSPF on a multi-access network like Ethernet. Okay. So OSPF, the routers are sitting there, and by default, every router is in a down state. It has not received a hello packet. First thing you do then is you send a hello packet. And this is when you get a hello from your neighbor, you go into what's called the init state. Now there is an error. If you ever have one-way communication between 2 routers, in other words, for some reason you can send a packet across but not receive one, it is possible for a situation called stuck in init. So if you ever see 2 OSPF routers and they will not transition, their neighbors, they will not transition from the init state to the 2-way state, I would investigate whether or not for some reason there's a one-way communication set up between those 2. Could be an ACL, could be just a problem with the circuit or something of that nature, but that's what's called stuck in init. If things are working correctly, you should go from the down state to the 2-way state very quickly, because this means both sides have seen a hello packet from their neighbor, and they will do their BR and DDR election if you're on a multi-access network. You then go to XStart. All right, and they basically determine who's going to be the lead in sending the database descriptive packets. Then they start sending those packets. And once they have all those packets, they go into a loading state and then finally full state. Yeah, go ahead.
It is at that 2-way state is when the 2 routers can determine if they can't communicate with each other, correct?
Well, typically, no, it's actually here. If they never transition to the 2-way state, then you're stuck in init.
So is that in this state where they talk to each other and say, well, I operate on this and operate on that, and we can talk to each other. So they establish that they can talk at the init state.
Exactly. Yeah, but it's kind of almost like the three-way handshake in TCP. This is when the SYN and SYNAC and ACK have all been received. But in this case, what happens is the two routers have successfully sent to each other hello packets.
Okay, and so once that's established, then they determine who's gonna be the lead. Who's gonna take the
Exactly.
lead.
Exactly. They will do, first off, they'll do two things. One, if they're on a multi-access network like Ethernet, they will do a DR and BDR election. Okay. If they're not on a multi-access, so they're on a point-to-point link, they'll transition. And by the way, after they do the BDR and DR election, they will translate to XStart even on a non-point-to-point network. Okay, because they're going to decide the sequence numbers. It's a little different on a multi-access network because everyone sends their information only to the DR, and then the DR sends it out to everybody else. Okay, but they're going to transition to XStart. Then they go to the exchange state. Now in the exchange state, the difference is going to be in a point-to-point link, they're just exchanging them with one another. But in a multi-access network, they exchange it with the DR, the designated router. And we'll talk about that in a little bit. Okay. Loading state, we've got most of our LSRs, LSU, and then we will actually run the SPF algorithm to find the shortest path first. Remember what again figures out what the shortest path will be? It's the metric. And what is the metric for OSPF?
The recipe thing, you talking about that algorithm that they use to calculate?
Yeah, but what is the metric for OSPF?
Cost.
You talking about no, I'm thinking about the administrative distance.
Yeah, you think about administrative distance. No, John said it cost. It's the cost of the links. And by the way, they've had to redo the cost on a lot of the links because it used to be that a gigabit, a 10 gigabit, and a 40 gigabit link would all have the same cost of one. So they had to redo the cost to handle the faster Ethernet speeds. Okay. So here we're in the down state. We send over a hello packet, go into the init state. Once we receive a hello from my neighbor, we then become the two-way state because we now have a neighbor in our neighbor relationship. If we're on a multi-access network, we will then do our election. By the way, the election is handled by looking at the priority of the particular devices. We'll talk about that and what the default priority is and how that works out a little bit later. We're not going to do that right now. We'll decide who the first router is going to be. Okay. And usually that's done by the router with the highest router ID will be the first router to send its database description packets, and then the next. You can set the router ID. That's just the router ID can be set inside of your configuration, or it's either going to be the highest IP address on any loopback. And then if there's nothing on it, first off, you set the router ID. So it's the router ID that's been set, or it's the highest IP address on any loopback, or it's the highest IP address on any physical interface, or it won't work. Okay, let me show you something. It's interesting. Let's go over here and look at this router. Okay, here's R1. And I'm going to show you. Show IP brief. You'll see there's no IP address on this router at all, nowhere. Okay, so if I go to config T and I do router OSPF 1, okay. Notice OSPF process 1 failed to allocate unique router ID and cannot start. So OSPF cannot run because there's no way for it to have a router ID. I didn't set the router ID. There's no IP address on the loopback. There's no IP address on a physical interface. OSPF cannot run on this machine. Now what I can do is this. I can do router ID 1.1.1.1. Now the OSPF process can run. You'll notice it'll work. So if I do show protocol or do show IP protocol now, you'll see that OSPF is actually running. OSPF 1 is running. Router ID is this. Watch this. If I go back to R2 over here, I do router OSPF 1. It'll bark at me. Do show IP protocol. See, OSPF is here, but it's not running. There's no router ID. There's no way for it to actually work. So the process didn't start. Failed to allocate unique ID and cannot start. So if I do show process. Pipe OSPF, so I can find it. Yep. Show process. Show process. It's kind of hard to see. We could find it in here, but there you can actually find the process running in here. By the way, this is something a lot of people get confused by. The ID that we used when we did this, that number right there, I know they call it an autonomous system number in the configurations. It's not an autonomous system number. It is quite literally just a place for the process to hang out. It's like a PID in Windows. If you know what a process ID in Windows is, that's all it is. It's a PID. They do not have to match among the members of an OSPF network. So it's not like EIGRP, and EIGRP, it truly is an autonomous system because they have to match for them to exchange routes. OSPF doesn't carry. This could be OSPF 1, the other side could be OSPF 28. Makes no difference. Okay.
So since we defined the process, we can have multiple OSPIS instances running, couldn't we?
Yes, you can. Yes, you can. Now, why you would do that? Well, I tell you where you would do that. You would actually do that with what's called virtual routing and route VRFs. You do it with VRFs, and you can create different instances and associate them with a VRF. But you actually would do that more inside the VRF instead of doing it with the process ID. Yeah, but it would be, yeah, it'd be the different VRFs running the different processes. So that's how you could do it. Yeah. If you don't know what a VRF is, that's okay. Basically, they've got a way now inside of Cisco routers to kind of chop them up into different virtual routers. So one single router can be turned into multiple VRFs or virtual routers and forwarding entities, so that an OSPF or an ISP could take a big honking router and run a bunch of VRFs on it and support multiple customers. But that is, way beyond the CCNA, but that's what that is. It's just basically a built-in function in the Cisco iOS to let you chop a router up into multiple different sections. It's really neat too, because technically the VRFs don't even know the other exist. So it can be a security thing. So you can be running this customer's information over on this VRF and this customer's information on this VRF, and the two won't even know they're running across the same physical router. They have no clue.
So then at that point, wouldn't we have to use like virtual IPs at that point, wouldn't we?
Oh yeah. Each
Okay.
VRF would have its own
Yeah, I'm
set
sorry,
of
I'm
IP.
getting off the subject. I'm sorry.
No, but yeah, but each VRF would have its own set of IP addresses, and technically though, you can even use the same IP set of IP addresses in the VRFs because they have no clue that they're even there.
Right. It's like
So,
a VLAN, just about.
Yeah. But it will cause some. You have to be careful with using the same IP addresses, because as you get further out of the VRF, things can get really wiggy. So at some point, they gotta get away from each other and not be the same. So, but the important thing there is, again, the one with the highest router ID, they'll start exchanging database description packets. If they need something, they'll send it during a link state request. Now, here's something interesting a lot of people don't know. OSPF does use triggered updates. So if something changes, they do link state requests, they get link state updates. But also every 30 minutes, they will ask for any updates, just in case something has changed that they missed. So it's not like it never asks for updates. They will do a request every 30 minutes. So link state updates are sent every 30 minutes if no change happens before then. So, and again, they call it incremental updates.
Hey, Kelly,
Yeah.
just as an aside, going back to the router screen, what command did you enter to get up to show all the process stuff? What did you run?
Do show process. I just
Oh,
did,
okay. All right. Yeah.
everybody knows you do if you're inside of global config.
Sure.
If you're not inside of global config, it'll just been show process. If you actually do process, there it is. That shows all the processes going on. And I actually, if I knew, let me try something here. Let me try to pipe quotation OSPF, see if I can get OSPF. Nope. Include OSPF. Oh, it's not running on that one. Nope, it was run on that one. See if we can find it anywhere in here. I don't remember what the process is called underneath. So I'd have to look it up, y'all. I have to find it, but that will show you all the processes on the router, show processes. And do remember, like I said, if you're inside of configuration mode and you want to do a show command, just type show in front of do show, whatever. And that'll let you run it. So on this one, I just do a router ID on it, and router ID 2.2.2, boom, do show IP protocol. And you'll see now I have a router ID, and that process should be running at that point. Okay. Okay, now everyone, we are at the section on the need for a DR. I'd like to pick back up here next week. So we'll start talking about why we have a DR and why DR elections are necessary. You'll notice this because of Satan. No, I'm just kidding. But it does look like a pentagram. It's actually due to adjacencies, due to the fact that if you don't, in a multi-access network, if you have to establish an adjacency with every single router, it creates an enormous number of adjacencies, and it causes you to have a massive topology table. And so just be aware that's the reasoning behind it. But we'll go over that, and then we will also get into next week how to do actual OSPF single area configuration. So we'll jump through and talk about wildcard masking, setting up OSPF, and everything in that. Okay. Any questions? I'll show y'all something. Look at that. In the time that we've been here, see if I can get it to load. That's what's printing, by the way, a bunch of buildings. But look, that's how much is already printed in less than an hour. It's crazy fast. So it's been sitting over here just plugging away. Thankfully, it's in the basement. Any questions on class? Any questions about what we're doing? Everybody comfortable about where we're going? Your first assignment's not due to the 20, I believe it's the 26th. So we've got a while before things are actually due. But obviously, if you want to work ahead. You are more than welcome to. If you have any issues getting into NetLabs, let me know, and we'll get those fixed as soon as possible. Remember, I sent out the email with the names and your password. If you had a previous password, it should still be that. If not, it should be Cisco123. Okay.
All right. Thanks a lot.
All right. Thank you, everyone. If you have any questions, let me know. I'm going to stop